Yep, quadratic formula. So there will be numerous ways that we will solve. One way to solve we already did, graphing. We could graph it physically, or we could use our calculator and solve for the x-intercepts, the roots of the zeros, right? Same thing. 2, we could do factoring. But can we factor every single thing that is ever given to you, any trinomial, or can they all be factored? No. Incorrect. So you cannot factor everything. So factoring is great, but if you can't factor it, you're stuck, right? So in instances where you can't factor, the quadratic formula is the way to go. Okay? Now, if you could factor it, could you still use the quadratic formula? Absolutely. The quadratic formula will work the whole time, but it is one that always works. So if you can't factor, you might have to do the quadratic formula. What is the quadratic formula? It's on your formula sheet. It's given to you. You won't have to memorize it, but it is this. X equals negative b plus or minus the square root of b squared minus 4ac, the whole thing over 2a. And then they say where ax squared plus bx plus c equals 0. So your quadratic needs to be in that form. And it's actually on both the 30-2 and the 30-1 formula sheet. It's at the very top of the 30-1 formula sheet, and it's at the very bottom left of the 30-2 formula sheet. So as you can see, it's going to get used in both 30-1 or 30-2. It's not going anywhere. If you're like, oh, I'm doing 30-2, here, right here. Okay. Now it says here, for ax squared plus bx plus c equals 0. They even tell you that on the diploma, okay? If your equation is not equal to 0, you need to make it equal to 0 in order to put it into this equation. Yeah, you're correct. So if it's in vertex form, you'd have to expand it out if you had to use the quadratic formula. Okay, so we are going to say solve for the roots using the quadratic formula. Hey. So we're going to have 9x squared plus 12x equals negative 4. 9x squared plus 12x equals negative 4. Now, some people might say, well, I don't know, they could say I could take a 3 and an x out of the first two. Would I want to do that? No. Quadratic formula, all you literally want to do is move everything to one side, set it equal to 0, and have no brackets. Brackets is a problem. I need to have it in the form ax squared plus bx plus c equals 0. Do these have to be plus signs in front of here? No. Okay. But then you will use the sign that's with it in that case. So I'm going to move the 4 over because I can't use the quadratic formula until it's all equal to 0. So 9x squared plus 12x, and to move that 4 over, I'm going to add it. So plus 4 equals 0. So if I could take a GCF out, would I? For the quadratic formula? No, because we want it in the form ax squared plus bx plus c. You need it to be in this form. Does this form have brackets in it? Yeah. So if you could take a GCF out, technically you could use the bracketed form in the quadratic formula and still get the same answer, but a lot of people get totally thrown off. So if you do not take a GCF out, let's say, and use A, B, and C, it'll just end up reducing the fraction in the end. So you could do that as well. But if you took a GCF out, you just have to remember that that GCF just sits out in front, and this would be your new A, B, and C, would be what's in the brackets. Okay, and ignoring the GCF out front. So you could take a GCF out, but you have to make sure that you don't use that anywhere in the quadratic formula. Yeah. Boys. if your b is negative, it will become positive, yeah, in the beginning. And it, yeah, in that one spot, yeah. Okay, so we know our a. Our a is positive 9 because in front of the x squared, why? This board shaking so much. A equals 9. And it's a positive 9. You always take whatever sign's in front. B is what's in front of the x. So B in this case is positive 12. And C in this case is 4. Okay, so let's fill this into our formula. We're paying attention so we're not lost. Yes? No. So, you can when we're done this. I don't want you to miss this. I'm not. Okay. So x equals negative, because the formula is negative b. What's b? 12. So if b was negative 12, it would actually become positive. So we're going to get negative 12 plus or minus the square root. We're going to explain this in a second. 12 squared minus 4 times a times c all over 2 times a. You have to remember that this whole thing has to be all over it. Okay? The reason why there's a plus or minus sign is because with quadratic functions, the maximum number of x-intercepts you can get is how many? 2. That plus or minus sign, we're going to use the plus once of the one of the times, then we're going to use the minus sign the other time, and we'll get 2 x-intercepts. Or we could end up getting 1 x-intercept that's the same, or we could end up getting no x-intercepts, and we're going to see how that works. So let's figure this out. We get x equals negative 12 plus or minus 144 minus what's 4? What's negative 4 times 9 times 4? 144. So we have minus 144 over 18. So I'm going to get x equals, yeah, just wait, x equals negative 12 plus or minus the square root of 0 over 18. Do we agree? Yes. Okay. Now at this point, you're going to split it up. At this point, you're going to split it up. You're going to get x equals negative 12 plus 0 over 18. And you're going to get x equals negative 12 minus 0 over 18. What does adding 0 and minusing 0 do? Absolutely nothing. So we're actually going to get negative 12 over 18 for both, which reduces to what? You can take 3 out of each of them. Negative 4 over 6. Oh, you can take a 4. You can take a 6 out of each of them. The square root will never be a decimal. The square root will be a number, and you'll never turn it into a decimal unless it's numeric. We will, but we'll see that in a second. I don't want to discuss that until we're done this. What? So we ended up getting two answers that were the exact same. Remember when we just did factoring and we got x minus 5 and x minus 5, and then we got 2 answers that were x equals 5 multiplicity 2? This is going to be x equals negative 2 over 3 multiplicity. So this little number under the square root sign, that b squared minus 4ac, that's under the square root sign, that b squared minus 4ac, it's called the discriminant. Okay? The b squared minus 4ac is called the discriminant. Whatever's underneath that square root sign is the discriminant. So what can you tell me from this example then? If b squared minus 4ac is equal to 0, what happens? If what's underneath that square root sign, in this case, happened, this is b squared minus 4ac, the 12 minus 4ac, you got 144 minus 444, which gave me 0. So my b squared minus 4ac, what was underneath there, that discriminant, was equal to 0. What could you tell me about your answer then? They're the same. How many x-intercepts are there? So when your discriminant is equal to 0, you get One real and equal root is what it's called. We're going to look at the discriminant in big detail, but right now let's just discover what it's going to do. So if underneath that discriminant we have equal to 0, we're going to get two that are exactly the same, correct? So we actually get one real and equal root. We're going to do a lot more. Okay, look at this one. So this is B. We're going to solve by the quadratic formula. 3x squared minus 5x plus 9 equals 0. Okay? So the very first thing we need in order for us to use the quadratic formula is we need it to be in A, B, and C, ax squared plus bx squared plus c form, right? The signs can be positive or negative, that doesn't matter. So we know that A equals 3. We know B equals negative 5. And we know C equals 9. Please fill it into the quadratic formula. See how you do. So when we fill this one in, we are going to get x equals negative and negative 5. So positive 5 plus or minus the square root of negative 5 squared minus 4 times 3 times 9 all over 2 times 3. So it's going to equal 5 plus or minus positive 25, because remember that needs to be in brackets. If you're telling me that's negative 25, it's not true. Negative 5 squared is negative 5 times negative 5. And then negative 4 times 3 times 9 is negative what? Over 6. So we get 5 plus or minus square root of negative 83 over 6. Can we take the square root of a negative? No. How many x-intercepts are there? None. If you punch 3x squared minus 5x plus 9 into your calculator, the entire graph is above the x-axis. The entire graph is above the x-axis. Yeah. So there's no zeros. So what can we say about the discriminant now? Yeah, you get that. B squared minus 4ac is less than 0. And we have no real roots. Thank you. Sorry, your pay is really poor. And by poor, I mean you aren't being, yeah, 0. Okay. So, if b squared minus 4ac is less than 0 just means negative, we have no real roots, which means the entire, it means the entire graph is either completely above the x-axis or below. Yeah. Yes. Zeros, x-intercepts, roots all mean the same thing. Okay? All right. One last one to try. Negative 2x squared plus 3x plus 8 equals 0. We'll solve this one together. So remember, the very first thing you would have to do, I'll explain why in a second, why not. So what we're going to do is we have to have it equal to 0. So we're going to have A, B, C. So we're going to have x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So x equals negative 3 plus or minus the square root of 9 plus a really large number. 64, not a really large number. I didn't skip a step. 3 squared is 9. And then we go negative 4 times negative 2 times 8 is positive 64. And so now we have x equals negative 3 plus or minus the square root of 73 over negative 4. If I wanted it as a decimal, you would split it up now. But if I say exact values, you're actually done. Because the 73 cannot be broken down anymore. Okay? So what happens if my answer had been, pretend, so it's totally separate, this is not my answer, don't say, where'd you get this from, Lepp? It has nothing to do with the question. It does. Nothing to do with the question. So say it was 2 plus or minus the square root of 24 over 4. Let's pretend that that was the answer. It's not the answer. Let's pretend that was the answer. This is a good answer, but it won't be there. Because what they're going to do is they're going to reduce this 24. 24 from grade 10, 24 can be broken down into 4 and 6. 4 times 6 over 4, right? Now, what's the square root of 4? If I take that out? 2, so that's why we split up. So we get 2 plus or minus 2 root 6 over 4, which is a great answer, but also wouldn't be there. What they do then is if you can take the number out of all three, you do. So here in the front of the root and down here, I can take a 2 out of each. So this 2 would become a 1. This 2 would become a 1. This 4 would become a 2. Can I ever just cross it out of the radical? No, the only way I can take it out of the radical is if it's a perfect square. Like I broke it down to 4 and 6 and I took the 4 out, it became a 2. So the answer to this one would be 1 plus or minus root 6 over 2. If that had been the answer. This one up here is awesome. It's 73. You can't break it down. Yay. So if it said exact values, you'd be done if it said exact values. Now, if it didn't say exact values, you have to split it up. You'd have to go negative 3 plus square root 73 divided by negative 4 and give me a decimal. And negative 3 minus square root 73 over 4. So what does this actually give me when that root is big like that? How many x-intercepts? 2. So if b squared minus 4ac, if that discriminant is positive, if that discriminant is greater than 0, you get 2 real and distinct roots. Yeah, so it's greater than 0. I said negative before. So you're going to get 2, right, when that discriminant is greater than 0? So I'm going to give you a few questions to work on. So write these down. Page 254. If you don't practice the factoring ones and you don't practice the quadratic formula ones, you'll find them hard when they're actually really easy. So you need to practice. You need to do your homework. Yeah. Number 3 says exact roots. So do I turn them down to decimals if I can? No. Number 4 says use the quadratic formula to solve each equation and express your answer to the nearest hundredth. Do you keep it as a radical? No, you go to the nearest hundredth. And number 5 wants the exact value and nearest hundredth. What's up? No idea what you're talking about. It's perfect. We're discussing discriminant and then solving by completing the square tomorrow. Remember, this is something to note. Thursday, so what happens is tomorrow is our last lesson. Okay? Yeah.